Hello, good evening, my dear JEE warriors. Welcome aboard to the Vedantu JEE English channel. And this is the part 2 of Motion in 1D, where we do all the kinds of concepts which are involved, all the important theory which is involved. I'll be doing it over here with handwritten notes, which will be sent to you after the class, along with the questions and PYQs. And those of you who missed the previous lecture, you have two options. One option is you can just check it out over here in the past sessions. Where is it? Motion in 1D. This was the part 1. Second option that you guys have is, as you are watching this particular lecture, in the description box of this video, you are going to get something called as the Jungle Book, which has all our playlists, all our lectures sorted right over here. Just click on this particular link. You can see this will open the Jungle Book, which has all the lectures, all the notes, all the PDFs, everything. The DPPs are also up and running. You can see you can download these DPPs. These are all PDFs. You will have to create your Vedantu free account, obviously. Okay, so everything is there over here, whichever lectures have happened. All right. Okay. So these are all the links that you would need in the Jungle Book. Right. Perfect. So let's begin with the class, my dear warriors. And let's start. This is your Captain Shreyas. Good evening, Manisha. Hello, Mahindra, Dhana, Tomato. Wow, such a nice name. Grishma, Vamsi, Herborine, Divya. Good evening, my dear warriors. Let's begin with the class and let's quickly start with the lecture. Remember, last lecture we have done motion, we have done all these things. Okay, distance, displacement, velocity, acceleration, equation of kinematics, graphs, everything. We have done this. So the notes are already shared. Now it's time for free fall motion or motion under gravity. Okay, so let's begin. Now, one of the most commonly observed phenomena around you when you are playing around is exactly this free fall motion. You play football, you play basketball, you play cricket, you play tennis, you play, for example, catch, or you are playing baseball, you are playing golf, you are playing any kind of sport. Most of the times you will see it has to do with motion under gravity or free fall motion, projectile motion, and stuff like that. So it is the most widely observed thing, especially if you are playing outdoors. Hopefully you play outdoors and not just stay indoors, my dear warriors. So don't waste too much of time on your mobile screens or laptop screens. Always go out, refresh yourself. Correct? Okay. So there are two kinds of motions that we discuss in JEE physics. One motion is motion in 1D. Second is motion in a plane for gravitational effects which are going to be applied on these objects. So motion in 1D means you are throwing an object, it falls down. You throw an object up, it goes up and comes down. You are on top of a building, you throw it up, it comes to the same height and continues the journey. These are all straight line 1D motions. Whereas motion in a plane, motion in 2D is you throw an object at an angle. It goes like this and falls here. You're on top of a building and you throw something, you throw a water balloon on your friend down. So it is going at an angle, it's going in a curved path. That's motion in 2D or motion in a plane. Right now, since we are continuing motion in 1D, we'll do only vertical motion or basically motion in a straight line, and we'll see the equations, the formulas, etc. for it. Now, one more thing that you should also realize is that whenever we solve the problems for motion in 1D, motion in 2D, effects of gravity, we neglect always one thing. And that person whom we are going to neglect feels very bad. Every JEE or NEET teacher or every JEE or NEET student will always neglect that, and that is none other than your air resistance. Correct. So for all the physics students, physics teachers, yep, remember, air resistance is something which we always neglect whenever we study motion. Why do we neglect air resistance? Is because the air resistance formulas are little bit on the complex side. The equations that they give are little bit complex, and apart from the basic stuff which you will be learning in the chapter of fluids, the motion is so complex that you will need higher knowledge of mathematics, complex differential equations, sometimes even nice different ways of applications of integrations and differential equations and all of that. So that's the reason why you neglect it. So for now, air resistance is neglected, which is a fair assumption. The air resistance anyways has decent effect, not so much, which we are okay. All right. So you always build upon concepts slowly from, you start with addition, subtraction, then you go to multiplication, division, then you learn powers, and then you learn roots, and then you go to integration and derivatives. So you always start from the basics. So it's a fair assumption. Now, anything which you drop under gravity, anything that you drop under gravity always falls down in an accelerated manner. Meaning, say for example, if you drop something in 1 second, if it moves this much, in the next second, it will move even more. In the next second, it will move even more, and so on and so forth. The distance keeps on increasing. If this is one time interval, 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 you will notice that this distance, if it was x, assuming that this particular object was dropped, you will see next instance this will move an amount of 3x, next instant it will move an amount of 5x, 7x, and so on and so forth. Basically, odd numbers ratio. So whenever you drop something, it is not going to do a uniform motion. It will have an accelerated motion. And that is why you will see the distances which it travels in the same interval of time is also going to be different. Do you remember this? How many of you remember this from the previous lecture? Why is it 1:3:5:7? Well, that proof I had given to you in the previous lecture, my dear warriors. And this is me in the current lecture. In the previous lecture, here, guys. I was here. Previous lecture, you can open up the previous lecture, motion in 1D, and I have told you about this Galileo's ratio for all of you. Okay, this Galileo's ratio for all of you in this particular previous lecture. You can check this out. I've done the beautiful derivation also for that. Where did it go? It's somewhere in this particular lecture. Yes, over here. See, this was the proof which I did. 1:3:5:7. You can check that out. It's a beautiful proof. Okay, you're going to enjoy it. Right. So having said that, what is the acceleration due to gravity? What is the acceleration? What is the acceleration due to basically gravity? The answer is it is 9.8 meters per second square, which we approximately use it as 10 meters per second square for most of the problems, which is also approximately, you take the number pi, square it. Pi is 3.14. So 3 square is 9, 3.14 square will be close to 9.8. So pi square meters per second square is also a good approximation, useful in some problems. So this is the value of the acceleration due to gravity. Projectile motion next lecture giving with me. Okay. Yes, Surya, I will add the Gauss's law and application. Thank you for reminding me. I'll definitely let the team behind know to add the Gauss's law lecture. Thank you for letting me know. Hello, TM Plays at Games. Good evening, my dear warriors. Now that we understand what is this acceleration due to gravity and how much it is, by the way, this is an average value which changes from place to place. If you go to the North Pole, it is different slightly. If you go to the equator, it is different slightly. We will see those reasons in a separate chapter called as gravitation. For now, let's just take the average value and we are okay with it. Let's accept it as a fact. No issues with that. So this slide is also very important because it lists down all the key important aspects before you start the actual derivations and see the formulas. First of all, gravitational acceleration always will act downwards irrespective of whether the particle is going up or down. I have asked these questions even to passing out students. When a ball is thrown up, where is the acceleration due to gravity? They say up, and while coming down, they say down. Guys, it's not like that. Whether the ball is going up, whether the ball is on top, being dropped, or whether the ball is thrown at an angle, doesn't matter. Acceleration is always towards the center of the earth. It's downwards. It's always downwards at that particular place. It's never going to be at an angle or upwards. This acceleration, I just told you the magnitude is 9.8, but for calculations, we use it as 10. Even when you throw a body up, let's just take this example of throwing something, and I have this pair of shades, right, which I use usually at times, and probably it's also there in the thumbnail. So let's say, my dear warriors, I take this pouch on which my shades are. So I didn't want to throw it with the shades, and I throw it up. It goes up, stops. It goes up, stops. You probably have to watch this in slow motion. Whatever you are seeing on YouTube, also you have that option. It goes up, stops for a moment, and then it starts coming down. When it has stopped for a moment, a lot of you might think there is no acceleration, but no, it is accelerating. In fact, it's taking its small moment of time to change the direction. So as it went up, slowed down, slowed down, slowed down, stopped for a moment, and then turned back and came down. So even at that moment, when it is at the topmost position, the velocity is zero. Velocity is zero, but acceleration is not zero. In fact, it is still accelerating. It's just taking its time to turn around. It's like some Pandu was running, and he forgot about Champa. He slowly stops and then turns back and then goes back towards his Champa. So there is a moment of realization when you turn around. So velocity is zero, but acceleration is not zero. I hope this is very, very clear. Upward and downward motions are symmetric. Kind of makes sense. Whatever you do while going up, the same thing is done while coming down. When I throw this up, when I throw this pouch up, speed is 5 meters per second, 4, 3, 2, 1, 0. While coming down, it is 1, 2, 3, 4, 5. So whatever it does while going up, same thing it will do while coming down. In fact, if it took 1.5 seconds to go up, it will take 1.5 seconds to come down. If it was thrown, if I throw it with a speed of 5 meters per second, it will also come back on my hand with a speed of 5 meters per second. So the motion is symmetric. The motion is symmetric. Symmetry is there. Symmetry means my body, whatever is there on the right hand side and the left hand side is the same. I have an eye here, I have an eye here. It's not like if I have a hand here, I have a leg here, then it will be asymmetric. So there is a symmetry in the human body. Same way there is symmetry when you throw an object up. Whatever it does while going up, it does the same thing while coming down. It's like somebody's playing the entire motion of the upward journey in reverse. Somebody has recorded the video of it going up. Now you play it in reverse. It does the exact same thing, right? Okay. For a given problem, you can choose anything as positive or negative. Accordingly, the sign of G will change. Now, this is another question you ask many of the students in school, and they would be like, you know, when you throw a body up, they will say, sir, acceleration due to gravity is negative. And when you drop a body, they will say acceleration due to gravity is positive. My mind was blown when I listened to this. I'm like, who tells you such things? Please let me know who is that person. How can you say such things? It is going to really, make any physics teacher, a true physics teacher, angry, because it's not like when things are going up, acceleration is negative, and when things are falling, acceleration is positive. No, guys, acceleration due to gravity was always down. Acceleration due to gravity is always down. Hello, Malati. Hello to you. Glad you are attending the live. Acceleration due to gravity is always down. So it depends on you what you have taken as positive. Pandu says, for me, upwards is positive. Okay. Champa says, for me, downwards is positive. Pandu says, upwards is positive. Champa says, downwards is positive. So think about it. This body being thrown up, it's going up. Velocity is positive for Pandu. As it is going up, velocity is positive for Pandu. But for Champa, downwards was positive. So hence, this body which is going up, the velocity will be negative for Champa. So it depends what direction you choose as positive. Same way, acceleration due to gravity. Acceleration due to gravity is always down. So for Pandu, who assumed upwards as positive, the value of G will be negative. For Champa, who assumed downwards as positive, for her acceleration due to gravity will be plus 9.8 meters per second square. As simple as that. It does not depend on the body. It depends on the observer. I'm the observer. Yeah, I'm the observer, right? I'm the observer, right? Yeah, so it depends on me, not on this thing which is being thrown. Whether it is going up or down, G value will not change. Whether it is going up or down, G value will not change. It depends on who is making those equations, who is observing it. I hope this is absolutely clear. Preferably choose positive direction in the direction of the motion. This is preferably, it's suggesting, it's not saying, hey, you have to use the direction of the motion as the positive direction, because sometimes it is not in our hands. For example, I throw this, it goes up and comes down. It goes up and comes down. Which direction will you take positive? Because it is going up also and coming down also. I can take up also, I can take down also. So, usually if it is just going in one direction before turning, then that direction you take as positive. Otherwise, there is no hard and fast rule, like you will see. Okay, everybody got it till this point? Everybody got it till this point, my dear warriors? Good evening, everyone. Give me a quick thumbs up in the chat box right away, right now. Give me a quick thumbs up in the chat box right away, right now. Yes. Okay. Yes, in schools they take you. Don't talk about schools. Schools are banned in this. Schools are banned in this lecture. Okay, whatever they tell you in school stays in school. Like they say, there was a movie. Whatever happens in Vegas stays in Vegas. Whatever happens in Vegas stays in Vegas. So whatever happens in school stays in school. But whatever happens in JEE does not stay in JEE. It is applicable everywhere. It is applicable in JEE. It is applicable in CUET. It's applicable in BITSAT. It's applicable in any entrance examination. It's applicable in real life also. So you are learning life over here, my dear warriors. You are not just learning bookish knowledge. Correct. So let's study the equations of vertical motions due to gravity, the equations, what it would look like. So first of all, it doesn't matter whether a body is thrown up with some velocity, it goes up, comes down like this, or maybe just already somewhere here and throwing this body like this, or maybe I am here, I'm throwing the body with some velocity, it goes up and comes over here. It could be anything, guys, doesn't matter. At any given instant, let's say, for example, this is your x-axis, this is your y-axis, this is your origin, this is your x-axis, this is your y-axis. Okay, so x-axis, y-axis, origin, this is your x-axis, this is your y-axis, and this is your origin. Okay, at any given instant, this is at t. At some instant, maybe the object is here. At some instant, maybe the object is here. It could be some instant, guys, where you are trying to locate the object at some instant of t, at some instant of time. At some instant of time, the object might have some velocity. Finally, it might have some velocity. Finally, it might have some velocity. Finally, so I can use all my kinematic equations because acceleration is constant. So acceleration due to gravity is basically constant. That means kinematic equations are applicable. That means kinematic equations are valid. Kinematic equations are valid. For example, I can use velocity is equal to u. U is upwards, so u is upwards, so then I'll take positive. If u is downwards, then I'll take it negative. So u plus or minus, depending on what is upwards positive or downwards positive, accordingly we'll change it. But in this case I have taken upwards as positive, y-axis is upwards, acceleration due to gravity is downwards, so I'll say u minus gt. Why this minus came? Only because y-axis is upwards, I know acceleration due to gravity is downwards. Had I shown this y-axis like this, then this would not be minus, this would have been plus. Then that would have been plus. That's the only change. So understand, still I can use v is equal to u plus at. In this case, the acceleration will be minus g. In fact, you can also find out the displacement. Like you can see over here, this is the displacement, initial to final position. From here to here, this is basically the displacement. From here to here, what is the displacement? This is basically the displacement. So you can say S is equal to ut plus half into at square, where a is again minus g. So all the kinematic equations are still valid, my dear warriors. You can also use v square is equal to u square plus 2s. So v square is equal to u square plus 2 into a into the displacement s. And remember, this acceleration is again minus g because of the convention. Okay, all these equations are valid. All these equations are valid till this point. Okay, so if all these equations are valid, then we can find everything about this vertical motion. How much time it takes, what speed does it hit, how much time does it take to go up, how high will it go, all the things I will be able to find out. So let's take two main scenarios which are there in most of the problems. Two main scenarios. The first scenario that is there in most of the problems is basically you have a ground which is given to you, and then you throw a ball or something with some speed u. So it goes up, goes up, stops, turns, and comes back over here. So this is one kind of situation which is usually given to you, and you might have to find the total time of flight, Not just that, you might be also asked to find what is the maximum height. This is basically your maximum height till which it goes up. This is what generally you might be asked. Another type of problem which you specifically get is where you have a body and you just drop it. When I say drop, it is just left. It starts with no velocity initially. So it starts with no speed, gains speed, and finally might achieve some speed after some time. So let's say the final speed is v, and it has been dropped from a height of h, and the time taken to drop by height h is basically t. So this is the time of fall. Right? So we might be asked this time, this speed, this height. Here we might be asked what is this maximum height, what is this time, etc. So we're going to solve these questions. Okay, so these are the two major kind of questions that we might get. So I'll just create a duplicate just in case we need it. So let's say we start off with finding the maximum height. So you throw something, what is the maximum height that it goes up by? One thing you should be absolutely clear. At this topmost point, the velocity is 0, but acceleration is still there. Acceleration is not 0. And this is all for a moment. Velocity is 0 for an instant. Instant means very, very small time, dt time. For a very, very small time, the velocity is 0. Immediately it turns back. Correct? So, in order to find the height, which kinematic equation do you suggest? Hello, Usha? Yep. Hello, Krish? Yep, Harbora, and U is 0 for the... Why vertical motion due to gravity, Krish? Because we are studying motion under 1D, motion in 2D, then we'll study projectile motion. As simple as that. Yep. Obviously, we'll use the third kinematic equation. Correct, my dear warriors. You will need the third kinematic equation. V square is equal to U square plus 2as. But we need to decide the sign convention first. Without that, we should not proceed. Okay. How to find acceleration if it is constant or not? Yes, let me tell you. Well, I'll come to that for in general case, but for gravitational cases, always any object thrown near the earth, the acceleration is constant. It is found to be constant, and it can be proved also experimentally as well as theoretically. Theoretical proof you will learn in gravitation chapter. Gravitation, there is a separate chapter, 11th standard physics. Experimentally also, people have tried throwing many things, many objects, different places on earth, and they all have same acceleration right from the beginning till the end. So both experimental proof is there, theoretical proof is there for motion under gravity. For other things, maybe an object is going, in a straight line in horizontal direction, a car is going, so that is not motion under gravity. So for such cases, what happens? Either you know that the acceleration is already given to be constant, or you know the velocity is some constant into time. Reason being, because when you differentiate velocity, what will you get is k into dt by dt, but dv by dt is acceleration, dt by dt is 1, so acceleration will be some constant. So velocity is linearly proportional to time, or basically the velocity time graph is a straight line like this. Okay, that is one way of knowing it. Another way of knowing this is if position is some constant, let's say a into t square. Okay, it's a quadratic function. Then what happens when you take the derivative of this dx by dt? It will become a into 2t. Okay, dx by dt will become a into 2t. You take the second derivative, d square x by dt square, it will become 2a. This is nothing but your acceleration. So hence our x versus the time graph should be a parabola. Then you will see that the acceleration will be a constant. Okay, don't take it as a, don't confuse it with acceleration. I'll put it as alpha. So, in any of these cases, you will see acceleration is constant. I hope this is very, very clear. Is that understood? Prince, thank you for all the love from Tamil Nadu. Can you start the preparation from July? Usha, what is it? Some auspicious day in July, is it? 1st July? Why not now? Why not today? Why not right now, 25th June? Why are you going to wait for 5 days? What is going to happen in those 5 days? Please explain. You have to start right now. Why wait for July? I've already given the entire timeline. I have made a video only for you guys. Please watch that video. Entire schedule has been given. What to do every month, how to study, all strategy for 99.9 percentile. Okay? Yeah. Very good. Awesome. Awesome. Okay. Yeah. Anybody spamming, don't worry, they'll get blocked. Now, basically, people who spam are going to get blocked. Yes, don't worry. Okay. Great. Bala, how to determine the value of gravitational constant? Two ways, experiment. Second, gravitation chapter, which we'll study later on. Okay. So acceleration due to gravity comes as a formula in gravitation chapter. Okay. That's how you get that value as 9.8 meters per second square. Second option is you do experiments, just like they did 200-300 years back. Okay. All the doubts clear. Shall we go ahead, my dear warriors? All the warriors, shall we go ahead, all my lions? Supriya, I took your name too. Okay. No time now. What do you mean no time? What did change, Usha? From June to July, 1 month. Nothing has changed. You still have time. If you say you don't have time now, then you will watch one more strategy video after 3 months, how to crack JEE in 2 months. If you want to avoid that video, then start with the plan right now. Today is the day you start. If you think you cannot start today, then again after 3 months, you will watch some other video of how to crack JEE in that limited time. Okay, never say tomorrow again. Now, in this process, v square is equal to u square plus 2s. Final velocity is 0. Initial velocity is 0. Initial velocity is u. I am only considering the upward motion. And in the upward motion, because I'm going up, why not take upward direction as positive? That will be convenient for me. So, in this upward journey from here to here, final velocity is 0. Initial velocity is u only, whether you take positive or negative doesn't matter because it is getting squared, plus 2 into acceleration due to gravity is down. So why not put minus g over here? Displacement from here to here is h. Displacement is h. So just put that h over there. Put that minus 2gh on the other side. It will become plus 2gh. So therefore, this height will become u square by 2g. This height will become u square by 2g. So this is the maximum height which a particle will go. You tell me the speed, I know the acceleration due to gravity, I know how high will it go. It kind of makes sense. If you go on the moon, you might have seen those old videos of Neil Armstrong jumping on the surface of the moon. You might have seen they go really high. They jump, they go really high as compared to that on Earth. Why is that so? It's because of G. G is there downstairs. So if the acceleration due to gravity is less, the height that you go up is more. So on the moon, if you take the same ball or if you try to jump, you will go much higher. But on Jupiter, gravity is more strong. It is almost 2 to 3 times stronger than Earth. So if you try to jump on Jupiter, you will not go as high. On Earth, if you are going this much, in Jupiter, probably you'll just go this much. So it will be much less because G is stronger on Jupiter and G is also downstairs. I hope this point is very, very clear. Yes. Rambi, you have a separate Vedantu NEET English channel. Please follow that where I am only teaching you. So these lectures are slightly over NEET level. If you understand these lectures, NEET will be a very easy piece of cake. But yeah, I am creating NEET exclusive content also on the Vedantu NEET English channel. Next important thing is the time of flight. Can I find the time of flight somehow? Which equation should I use? A lot of you will say, sir, let's use V is U plus AT. Yes, you can use that. You can also use S is UT plus half AT square. So I will show you two ways of getting it. Tell me one thing. When this object goes and comes back over here, it will hit the ground with the same speed but in the opposite direction, isn't it? Why? Because the motion is symmetric. Because the motion is symmetric, the ball hits the ground, the ball hits the ground with the projection speed, with the speed with which it was projected. So projection speed, since the motion is symmetric, since the motion is symmetric, since the motion is symmetric. So if I use the equation V is equal to U plus AT and I let's say assume the upward direction to be the positive direction, usually upwards I can take positive, you can take downwards also, doesn't matter. In this case, the final velocity is having a magnitude of U, but sign wise it's down. So I think I should put minus U instead of V. See if this makes sense. The magnitude of the final velocity is U, but direction wise it is downwards as compared to upwards. So minus U. Initial velocity has a magnitude of U and it is upwards. So it is going to be plus U only. Plus, okay, I hope you understood why the minus and the plus signs over here. Acceleration due to gravity is down, opposite to the assumed direction. So it is minus G. And this time is the entire time from here, initial to final. Hence, it will be the total time, which is capital T. Is that right, everyone? So what do we get? Just take minus gt over here, it will become plus gt. Take that u on the other side, it will become u plus u, which is 2u. So hence the t will become 2u divided by g. This is the formula. So the total time to go up and down will be 2u by g. Also, this tells me one more thing. The time taken to go up is also the time taken to go down. And that will be t by 2, which is just u divided by g. So just to go up, u by g. Just to go down, u by g. So u by g plus u by g, 2u by g. That's the total time to go up and down. Okay, a very nice derivation. Okay, I hope this is very, very clear. Awesome. Anyway, we should probably have those kind of discussions like, in a nice group conference call or something like that in a casual session. What was there before Big Bang and stuff like that. Those are really fascinating discussions. I love to have those discussions with kids. It's a really interesting because there is no unique answer. You don't know the answer, and that's the best part about these discussions. Another way of doing the same thing is using the second kinematic equation, which is S is equal to ut plus half at square. For the entire journey, observe one interesting fact. For one entire journey, the displacement is zero. The displacement, because initial position is equal to the final position. I started here and I came back here, so the net displacement is zero. Perfect. So if I use the second kinematic equation, which is S is ut plus half at square, and let's stick with our standard thing, which is upwards as positive direction. So what do I get? S is 0. Initial velocity is upwards, so plus u. The time will be total time plus half. Acceleration is downwards, so minus g. And time is the total time because it's the entire journey. So that's why the time is total time. So now if I rearrange it, what will I get? Take this gt square by 2 here. I'm left with ut. Tt cancels. So gt by 2 is equal to u. So therefore t is equal to 2 times of u divided by g is exactly the same answer as before. Which is exactly the same answer as before. It's just a different approach, and you're seeing how different kinematic equations can be applied, and you're learning more about it. So I've proved the same thing in two different ways, which is very, very important. It's not about, sir, you got the same answer, what's the point? No, that's the point. We have to try our different approaches that will open up different ways of thinking, which is required in problem solving for JEE Advanced and JEE Mains. Correct. Shall we go ahead now to the next thing? And that is when you drop something from the top. When you drop something from the top, guys, and this object is starting with no velocity and gaining that velocity within no time. I want to find many things like what is the speed with which it falls down? What is the time that it takes? Let's start with the speed first, probably the easy one. Because it is going down, why not take downwards as positive? It's my choice, obviously. Somebody might say upwards is positive, no issues, you will get the same answer. So if I use maybe the first equation I can't use. Why? Because time I don't know. Correct? V is u plus at. I can't use it. Time I do not know. So maybe I need the third equation. So let's use the third equation. So V square is u square plus 2a into s. Final velocity v. Initial speed, because it was dropped, it was 0. Plus 2 into downwards is positive, acceleration is also down, so it will be plus g. Displacement downwards, downward direction is also positive, so it will be also plus h. Why plus h? Because downwards is taken positive and actually the displacement is downwards. So perfect, it is also positive. So 0 square is 0, so hence v square is 2gh. Therefore v is equal to root of 2gh. That's the answer. So the speed with which it hits the ground or after height h is root 2gh. You should know this formula. You cannot afford to forget this. Clear till this point? All right. So let's find the last thing, which is the total time of flight. How do I find the time of flight, time for which it stays in the air? First equation, yes. Second equation will be easy. Imagine, again, I take my downwards direction as positive, and let's go to the second equation, which is S is ut plus half at square. What is the displacement? It is basically plus h. Downwards is positive, initial is here, final is here, displacement is downward. So hence positive displacement. Initial velocity, nothing, because you dropped it. Drop means no velocity initially. Plus half into acceleration is downwards. So hence it is plus g. And time is what I need to find. That's why t is substituted as capital T. Hello Divakar, welcome back. Yep. So now rearrange and see what do you get. So h is basically gt square divided by 2. So t square is equal to 2h divided by g. So therefore t is nothing but root of 2h divided by g. That's the answer. So that's the time which it is going to take to fall down. Root 2h by g. Yep. Usha, make a backlog plan for 2 weeks. Every day in the night, sleep 2 hours less, complete those lectures at 2x speed, solve all the problems which I am doing here, plus which is there in the DPPs, plus your NCRT or whatever coaching book you have, and put in that extra effort, study more, sleep less, bunk your school or college wherever it is possible, as simple as that. Eat food for less time, spend less time in having baths. That's the sacrifice you'll have to put, and take 2 weeks to complete the backlogs. I think it is doable easily. Okay, take 3 weeks if you want, but complete it now, or else more backlogs will pile up. Shall we now do some questions? Sir, upwards means negative? No, not necessarily. It depends on the direction of your assumption. Velocity can cause fire when it rubs against the air. Air friction causes that burning effect. Okay. Yeah. Yes, you can bunk as in miss school. Yeah. It's up to you. All right. Let's do some questions. Let me ask you a very simple thing. In this journey, this ball is going up and coming down like this. This is point number 1, point number 2, point number 3. From 1 to 2, from 2 to 3, I'm asking you certain signs. What is the sign of velocity? What is the sign of acceleration? And there are two people. One is Pandu. For Pandu, upwards is positive. For Champa, downwards is positive. Okay, accordingly the answers will be different. Come on, let's do this question. Let's settle this debate once and for all. Okay, come on, my dear warriors. If you talk about velocity from 1 to 2, the velocity is upwards. Right? So upwards is positive. So for Pandu, the velocity will be positive. But for Champa, downwards is positive. So velocity will be negative in 1 to 2 region when it is going up for Champa. Is that making sense? Similarly, from 2 to 3, it stops, turns back and comes down. It is coming down. So velocity, the direction of the motion is velocity's direction. So that is negative because I have chosen upwards as positive. But for Champa, downwards is positive. Hence, velocity will be positive for Champa while coming down. As simple as that. Very good. But if you talk about acceleration for Pandu, whether you are going up or coming down doesn't matter. Acceleration due to gravity is downwards, so it will be negative for both the cases. It has to be negative because acceleration is downwards. Pandu assumed upwards as positive. Whereas for Champa, downwards is positive, acceleration is downwards, so it is positive both the times. Is that absolutely clear? How the sign convention works? Everyone? Clear? Give me a thumbs up if this problem has made things very, very clear. One more additional thing I can add. What about at the point number 2? Exactly at this point, what do you think will happen? Exactly at this point. Well, whether you take Pandu, whether you take Champa, the answer is 0. Whether you take Pandu, whether you take Champa, the answer is 0 for velocity, but acceleration wise, it is still the same. So acceleration is still there. For Pandu, it is negative. For Champa also, it is still there and it is still positive. That's what it is. Acceleration did not become 0. It's the velocity which became 0 at that particular point. Very nice. Awesomeness. Let's move to the next question coming up on your screen. A ball is thrown up with a speed of 4. Find the maximum height. We can also find the time also if that is asked. Come on, let's do this problem. This is introductory problem, level 1 question. I think that level 1 is not seen again for some reason. It's hidden over here. But anyways, the speed is given, the maximum height is asked. So if I throw this ball up with 4 meters per second, how high will it go? Use the formula. H is u square divided by 2g. U is basically 4. So 4 square divided by 2 into g. Usually we use g as 10. 4 square is 16. 16 by 2 is 8. So it will be 8 by 10, which is basically 0.8 meters. 0.8 meters is roughly this much. So it will just go this much. Yep. Everybody with me? How many of you got the answer? Perfect. What about if time of flight was asked? I know time of flight is not asked here, but if it was asked, the time of flight, if it was asked, it will be 2u divided by g. U is basically 4, G is basically 10, 2 4s are basically 8. So it will become nothing but 0.8 seconds. 0.8 seconds. Perfect. Perfect. Awesome. Coincidentally, both the answers came out to be the same. Don't get confused and think, so how come the answer came same? Don't worry about it. If the question was, what is the time taken to go up or what is the time taken to come down, then the answer would be the total time 0.8 divided by 2, which will be 0.4 seconds, which will be 0.4. 0.4 to go up, 0.4 to come down. If the question was, what is the total distance traveled? What is the total distance traveled? Think about it. It went up and came down. It went up, distance h, came down, distance h. So it will be 2h. So it will be 2 times of 0.8, which will be 1.6 meters. If the question was, what is the displacement? What is the displacement? Then the answer is even more simple. The answer is 0 meters, since initial and final positions are the same. Initial and the final positions are the same. Is that clear? So all these kind of questions can be asked using this simple data. Using this simple data, as simple as that. Hello, local YT. Great. Moving on to the next question on your screen. A ball is thrown upwards from the ground with an initial speed of u. The ball is at a height of 80 meters at 2 times, the time interval being 6 seconds. Find u, take g as 10. Very nice question. Without drawing the question, you cannot solve this. Without drawing the question, we cannot solve this. Okay. A ball is thrown upwards from the ground with some speed. The ball is at height of 80 2 times. Interesting. So imagine this is our ground level. This is our ground level. You throw this particular ball with some particular speed u, which I do not know, I'm not aware of, but it goes up, goes up, goes up, goes up, goes up, and reaches at some point of time a height of 80 meters. A height of 80 meters. And it reaches it twice. Why is it reaching twice? In an interval of 6 seconds. Because maybe it continues its journey even further till it stops and returns back over here. So it is reaching that height of 80 meters 2 times, once while going up, once while coming down. Is that absolutely clear? And this time interval, the total time interval is given to be 6 seconds, this entire yellow part. I don't know what the speed is here, but whatever is the speed here is also the speed here. And I also know at this point, the velocity is a perfect 0, exactly at the topmost point. So what is the first thing that we will do? Just look at only that yellow part, forget this part completely. If you just look at that yellow part, it looks like our first scenario where you throw a ball from the ground and it comes back at the same point, and the total time is basically 6 seconds, and this is the speed with which you throw it. This is exactly just like this one. Exactly just like this one. Whether what was happening before this, I'm not bothering. I'm just looking at this part of the problem. I'm just looking at that small part of a big problem, which is perfectly fine. So here I can use the formula time is 2v divided by g. Time is basically 6, v I don't know, g is basically 10, 2 goes with 6 3 times. So velocity will be 30 meters per second. But that is not the answer. Why? That is the velocity here. What they have asked is, what is the velocity u over here? What is the velocity u over there? Hello SK Talks. Okay, so we need to be very, very careful. How do I find that u? Maybe I need to apply something over here from here to here. Maybe I need to apply some kinematic equation. Which kinematic equation will help me from here to here? Speed, speed, distance. That's third kinematic equation. Final speed, initial speed, and distance is there. Third kinematic equation, I don't know the time. So let's use v square is u square plus 2as. Final velocity, well, that's 30. Initial velocity, I don't know. By the way, I have taken upward direction as positive. Let me tell you that. Okay. Acceleration due to gravity, well, that's down. So minus 10. Displacement is upward, so it is positive, and that is going to be just 80. So therefore, I will get u square as 30 square is basically 900 plus, because when it goes on the other side, the negative becomes positive, 8 twos are 16. So it will become 1600. So this will become 2500 is nothing but u square. Therefore, u will become how much? 50. So the answer for this particular question is 50 meters per second. Let's find out. Yes, it is 50 meters per second. Is that clear? So from the ground, it was thrown with 50. What did you learn from this problem? You learned sometimes a problem needs to be broken into parts, which is exactly what we did here. A part from here to here and second part from here to here. For each part, you can use your own equations or formulas. Like I saw for this part, I saw this is just like throwing a ball up and it coming back to the same point, total time being 6 seconds. So I use the formula directly. Another thing which you learned is maybe for some parts you can't apply any direct formula, but you have to go back to your original kinematic equations like this one. So I use the kinematic equations wherever necessary to solve the problem. Everywhere we followed sign convention, everywhere we followed strict practices of vectors. We saw the direction, we accordingly use the signs, and hence we got the answer. If you miss this minus sign, remember when you go to the other side, this will become minus 1600, which will make it very absurd. How can you subtract 900 with 1600? Okay, because the square term will become negative. So you need to be very careful with the signs. So all these things you learned in this problem. Next, a stone is thrown upwards with a speed u from the top of the tower, reaches the ground with a velocity of 3u. The height of the tower is. Interesting question. Read it again and then draw the diagram. Without drawing the diagram, we will not be able to get it. Okay, so let's think about the question. A stone is thrown upwards with a speed u from the top of a tower. Okay, let's assume this is the top of the tower and I have thrown it upwards with a speed u. It goes up, goes up, goes down, and when it reaches here, it has the same speed u and it continues its journey. Remember that, continues its journey till it hits the ground with a speed of 3u. Okay, it hits the ground with a speed of 3u. The question is, what is this height? The question is, what is this height going to be? That is the question, if I'm not wrong. Correct? It hits the, what is the height of the tower? Okay, I know one more thing though. For this entire journey, downward direction, if I take it as positive also, that would be get better, I feel, because everything is going down. And acceleration due to gravity is also down, so it will be positive. Okay. Nishan, don't spam. This is for both. If you spam like this, you will get blocked by the admin. Yeah. So now think. Time not given, not asked. Speed given, final given, displacement asked. So which is the most suitable equation? The one which does not have time. That's the third kinematic equation. So why not use that? The third kinematic equation, which is v square is u square plus 2as. Final speed is downwards. It is 3u. But even if I put minus, it doesn't matter because I'm getting it squared. So it doesn't matter whether I put minus or plus. Ignore it. U, initial speed is u. So I'll just put u square over here plus 2 into acceleration is downwards. So it is positive. So 2g. And displacement is also downwards. This is initial, this is final. So this is my displacement, which is positive. So it is again plus h. So this will become 9u square is equal to u square plus 2gh. So 2gh, 9 minus 1 is basically 8. So it will become 8u square. So gh will become 4u square because 8 cancels with 2 4 times. Hence, h will become 4u square divided by g. 4u square divided by g, which is option B. No, it is not IIT Delhi, it is IIT Bombay. Got it? Yes, Harborine, that's correct. Dharneshwaran, yep, be careful. I think you made a mistake. Yeah, it is not 9u square by g. Yep. Okay. Very good. Excellent day. Excellent day. Usha, I'll tell you, I was just like you when I studied for JEE in this aspect. I also never liked chemistry, and there were many reasons. It could be maybe I was not inclined towards memorizing and stuff like that. But there are two things which I'll tell you which are very important. Number one, once my teacher changed for organic chemistry, I had an amazing teacher. I don't know what happened, but I loved organic chemistry. And I felt that I loved organic chemistry because organic chemistry is logical. Then I later on realized it was not because organic chemistry was logical that I loved it at that point of time, but it was because of the teacher. So sometimes teacher plays a very important role. Sometimes the subject only is very good, or maybe you like it. So that's why the teacher does not matter whether it is whether the teacher is boring, interesting, good, average. You will still end up liking it because you love it. Number two, I thought maybe I can just pass JEE through organic chemistry, but that was wrong. I was able to clear JEE through organic chemistry, but had I studied inorganic properly, physical properly, then I'm 100% sure my rank would have been much, much better. So it's a bitter pill that you will have to take. Just like when you are sick, what do? You take a pill. You don't like the pill. You probably get admitted, you have syringes, you take injections. Nobody likes injections, but you have to take it because you want to get well. Same way, if you want to get into IT, you have to do it. There is no other choice. Later on, you don't have to study it depending on the branch that you get, but till then, you have to. There is no other choice. Okay, I can't make chemistry interesting suddenly for you. I can't suddenly make you like chemistry. If some teacher is telling you, you know what, I'm going to make chemistry very interesting for you, fine till a certain moment, but at the end of the day you too have to develop that extra interest. You too have to take that step. Understand that. Initially, if the stone is thrown upwards, then is acceleration negative g? Local yt, whether the stone is thrown upwards or downwards doesn't matter. Like I said, it depends on the observer. I'm saying this again and again. It depends on the observer. Whether the stone is thrown up, down, doesn't matter. Doesn't matter. Okay, it depends on the observer, what you have taken as positive. If you take upwards as positive, then negative. If you have taken downwards as positive, then positive. Depends. Okay. Okay, let's continue, guys. A body falling under gravity covers 2 points A and B separated by 80 meters in 2 seconds. This was a previous year JEE question. Leveling up, guys. The distance of the upper point A from the starting point is how many meters? Draw the situation, only then you will get it. Draw the situation, my dear warriors, only then you are going to get it. Body is falling under gravity covers 2 points A and B. A is not the starting point, B is not the final point. Remember that it can go further below and it has started much before A. So let's say you drop a body somewhere over here. It accelerates, 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 reaches this particular point A, accelerates, 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 reaches this particular point B, and the separation between them, how much is it? 80 meters. And the time taken for this particular journey from A to B is basically 2 seconds. That is what is given to you. Okay, when I say drop, that also means the velocity at that point was basically zero. Perfect. And I feel it is better that I take downward direction as positive, and all the motion is happening in the downward direction. So even G is downward. So G will also be positive. Okay. So what kind of equations can I write? What kind of equations can I write? Just think about it. What kind of equations can I write in this particular scenario? I don't know the speed at point A. Maybe I'll assume it to be something. Maybe I'll assume it to be something. Maybe VA. I don't know the speed at point B. I'll assume it to be something. Maybe VB. I don't know VA. I don't know VB. But I want to know what is this distance. That's exactly the question, guys. What is this distance? That is what the question is. The distance of the upper point A from the starting point. Maybe if I know VA, I can find this. To find VA, maybe just for this part, displacement is known, time is known, acceleration is known, initial speed is not known at point A. Maybe I can use the second kinematic equation. Just observe this. if I use S is equal to ut plus half at square, displacement is down positive, so it is plus 80. Initial speed is VA, time taken is 2 seconds, and plus half into acceleration due to gravity plus 10 downwards, time again 2, so 2 square. So check this out, what do we get? 80 is equal to 2 times of VA, 2 cancels, right? So it will just become 20. So therefore 2 VA will just become 80 minus 20, which is 60. Therefore VA will become 30 meters per second. Interesting. I found out VA. Wow, perfect. Now I know how to find this height. We just saw a formula for that speed. Remember, just some time back, if you drop something, the speed is root 2 gh. You can use this, it's up to you. Or if you don't want to use that, then use kinematic equations. There is no other option. Use, where is it? Use kinematic equations. Let's see. To find this particular height, we have two options. Either use V is root 2 gh or use kinematic equations. So let's use our formula because we have learned it for a purpose. So VA will be root 2 GH. This VA is basically 30. So 30 is equal to 2 into 10 into H. So squaring both sides, it will become 900 is equal to 20 H. Therefore, 0, 0 cancels. H is basically 90 by 2. Therefore, H is equal to 45 meters. So this distance is 45 meters. Perfect. Yep. You can use V is U plus 18. No, Nishant, reason I don't know this time. A lot of you said, sir, we can use V is U plus 18. No, I can't because I don't know how much time it took from here to here. Only from here to here, the time is 2. From here to here, it is 2. Here to here, I don't know. It could be more, it could be less. Yep, it is used here to solve with formula. Okay, okay, great. Moving on to the next question. Wow, a balloon is starting to rise from the ground with an acceleration of this. After 8 seconds, a stone is released from the balloon. The stone will, amazing question. How much time will it take? How much displacement will it have? Distance that it will travel and all of that. So I'll tell you one story. It's a very interesting and nice story. So what happened one day? Okay, let us draw our ground first. Oh. Pandu went into a hot air balloon. Pandu, okay, he went into a hot air balloon. He started from the ground. Our Pandu is over here and he started rising up and he's rising up with an acceleration. He's rising up with an acceleration. This is our Pandu. After some time, Pandu realizes that, Champa did not come with me. Pandu is going alone. And Champa did not join him in the hot air balloon. So this Pandu, who is there, he decides that because Champa did join him for this beautiful journey, in this romantic journey in this hot air balloon, so he decides maybe he should show some gesture of love. So he has a nice heart-shaped stone. So he has a nice heart-shaped stone. Okay, nice stone. He drops it as he's rising after some time. And Pandu continues to go up, obviously. Pandu will continue to go up. After this, there is no relation of Pandu with that particular stone. There is no relation of that Pandu with that stone. This stone will eventually land. This stone will basically eventually land on or close to, hopefully not on Champa's head. Champa is over here. This is our beautiful Champa. And this stone heart-shaped stone will land near Champa, and Champa becomes happy, impressed by Pandu's gesture, and maybe next time she will join the journey. So this is this entire scenario, whatever is there in this particular problem. Okay, whatever is there in this problem is exactly this scenario in a very nice, beautiful story form. Yeah. So concentrate on the problem. I know you guys have a lot of questions here and there of this college, that college. Concentrate, guys, or else my flow of thought will break. Now, as this Pandu goes up, don't you see this Pandu also has some velocity? The balloon also has some velocity. The stone which is carried with the Pandu also has the velocity. So after some time, the Pandu, the stone, the balloon, the hot air, everything has the same velocity. How much velocity do they have? We can find it out because he drops it after 8 seconds after accelerating for 8 seconds with 1.25 meters per second square. So realize this, his going upwards with an acceleration of 1.25 meters per second square, and this is exactly at 8 seconds that he drops this particular stone. He basically drops that particular stone. Even that stone has that same velocity. How much is that velocity? We can easily find. If I call that as u, if I call that velocity as u, we can easily find that out using v is u plus at. Using final velocity is initial velocity plus acceleration into time. Final velocity is u. Okay, initial velocity, this particular Pandu started from rest. So it is 0. Acceleration is 1.25 multiplied by the time, which is basically 8 seconds. Everybody fine till here? Everybody fine till here? Let me know. Which direction have we taken as positive? Yes, we have taken upwards as positive. We have taken upwards as positive. Correct. So what will be my final velocity over here? 1.25 into 8.25 into 8 is 2. So 2 plus 8 is 10. So it will be basically 10 meters per second. So the stone, the balloon, the Pandu, everybody has 10 meters per second speed. At the moment the Pandu drops, what do you think will happen next? A lot of people think the stone will fall down. That is wrong. The stone won't fall down, guys. The stone won't fall down. Why? Because the stone already has some velocity. In fact, it is 10 meters per second. So in fact, what will happen is the stone will continue to go up till some point and then take a U-turn before falling down. So it is still going to go up for some time before turning around and falling down. Everybody agrees with this? Everybody agrees with this? Will gravity not influence the hot air balloon? Yes. So actually there are multiple forces in this. Gravity is there. Hot air balloon experiences something called as the buoyant force. So the buoyant force is larger than the gravitational force. Hence it is going up with 1.25 meters per second square. This is the resultant acceleration. A lot of you might think, sir, should I subtract or add g to it or 10 to it? Answer is no. All that has been already factored in. It has been taken into consideration. Whatever acceleration is given is the final acceleration with which the balloon goes up as a result of gravity, buoyant force, resistance, everything. I hope this is clear. Okay. Okay. Yes. What limits? What limits? Yep. The stone has the same initial velocity as a balloon when he drops. Yes, alpha. Correct. Yep. Awesome. Hello, Muskan. Everyone, come on. Focus, focus, focus now. Now observe. Now observe. What is the height from which he drops? That also we can find. That's not a big task, if you ask me. What is the height that this balloon has gone up by? This height can be found by using S is equal to ut plus half at square. What is u? 0. What is acceleration? That is 1.25. What is the time? That is basically 8 square. Everybody with me? Understood? I also need that height. Why do I need this height? Check this out. I think something about the distance and displacement is also mentioned in the problem. That is the reason why I need to find this particular height. Is that right, my dear warriors? Is that right, my dear warriors? Pakka? Very good. So how much does this displacement come out to be? Check this out. 1.25. 8 square 64 by 2 is basically 32. How much is 1.25 into 32? Come on. 1.25 into 32, guys. It will be more than 32. 32 into 0.25. So divided 4 times, it will become 8. 8 plus 32 is 40. So it should be 40 meters. Just check this out. 40 meters. Yes. So maybe we can eliminate few options. The displacement is of 50 meters, covers a distance of 40 meters in reaching the ground, begins to move down after being released. I think except for option A, B, C and D, we can decide which one is correct, which one is wrong. Can you guys quickly think and tell me? Can you guys quickly think and tell me which of these options are correct or wrong? Begins to move down after being released. That is obviously a big no. It goes up and then comes down. It is clearly seen over here. It first goes up, first goes up, and then turns, and then it comes down. And then basically it comes down. So hence 100% option number B is wrong. Has a displacement 50? Well, displacement from here to here is just 40. Initial, final. How much is this? 40. So it is saying displacement of 50. That is wrong. Actually, this 50 should have been 40 meters. That is what is missing over here. That's why C option is wrong. Covers a distance of 40 meters in reaching the ground. That is a big dilemma. A lot of you are going to say option D, and I can see everybody spamming answer D. That's wrong. That is why it is a level 3 question. Okay, maybe level 3 is not seen over here before, but level 3 question. Guys, the answer is not 40. Think about it. Distance, not displacement. It goes up, comes down, then 40. 40 plus x plus x. So it is more than 40, guys. It is more than 40. How can the distance be 40? It is more than 40. It is not 40 meters. Hence, D option is wrong. Got it? Understood? This is distance. Displacement will be 40. Distance is not 40. Realize this. It went up, came down. So this is initial, this is final. If somebody asks you displacement, this is the displacement, which is 40 meters. The distance will be 40 plus something. That is that something over here. If this is x, this is also x. So plus x plus x. It is more than 40. Got it? Yeah, we need to add that extra height. So it is obvious now A option is correct. You don't even have to break your head. But I mean, I cannot do that. If I did that, I'm not a good teacher. I just show you, see, these options are eliminated. Many people will try to do that trick with you. Oh, so option A is correct. Let's go to the next question. That is wrong method of teaching, obviously. And if you do this at home also, you have learnt it in a wrong way, or you are just using some shortcut. What is the guarantee that you can eliminate the options in the exam this way? Maybe there are two options that reaches the ground in 4 seconds, reaches the ground in 6 seconds. How would you know then? Hence, that is not right. So, what is the time? So, my dear warriors, my dear lions, a lot of you are going to suggest me, sir, this is just like that falling down formula. So, let us go back. Do I know that formula to fall down? Wow. Time is root of 2h by g. Can I use this formula or no? Can I use this formula or no? A lot of you will be like, yes, sir, why not? You have dropped here, you have dropped there. But that is my point. You dropped here, but with respect to the earth, the velocity was actually zero. So all these equations started with zero velocity. So that's why you got this. But think again, for this particular problem, my dear warriors, my dear lions, it is not zero. You are not dropping it from the Earth's perspective, from the ground perspective. For the Pandu perspective, yes, you are dropping, but Pandu is also moving. So you cannot use that equation. So I'll explicitly mention it. Can't use time is root of 2h by g, since initial velocity is not zero. He has not dropped from the Earth's perspective, only from his own perspective, and he himself is in motion. So the apple or the stone or whatever the object is also is in initial motion. Okay, so then what is the other alternative? I know one thing. There is this displacement. How much is the displacement? 40 meters. Displacement is 40 meters, sir. Downwards, sir. Okay. Acceleration is there downwards, sir. How much? 10 meters per second square. Okay. Initial velocity is upwards. How about I take downwards and positive and solve this entire equation now? Using S is ut plus half at square. S is ut plus half at square. Let's solve this, my dear warriors, and see what do we get. What is the displacement? Displacement is down, downwards is positive. So plus 40, no doubt about it. Initial velocity 10, up, downwards positive, upwards negative. So initial velocity minus 10. Time, I don't know. Acceleration, downwards, positive, 10. Yes. So time, do not know. Is that right, everyone? With me on this? Okay. 0, 0, 0 cancels. 4 is equal to minus t plus t square by 2. Multiply by 2. 8 is equal to minus 2t plus t square. Rearrange the equation. T square minus 2t minus 8 is equal to 0. This is a beautiful quadratic equation. What does the quadratic equation have? What does the quadratic equation have? Roots. Yeah, so what are the roots of this equation? What are the roots of this equation? Come on. There are two values, t minus 4, t plus 2, t minus 4, t plus 2. Is that right? These are the factors. So hence t is equal to 4 or t is equal to minus 2. But obviously time can't be negative. How can it be negative? Hence the only acceptable solution is the positive value. Hence the time is basically 4 seconds. And that is what is also there in the answer. Time is 4 seconds. Automatically the other solution gets rejected because of its negative nature. Because of its negative nature of time. Time can't be negative. So hence answer is A. We got the answer correctly. This was a nice, beautiful question on projectile 1D motion. Yeah, those are the questions, guys. I hope you enjoyed this class of free fall motion and you learned a lot, especially about the signs and when to use which equations and the formulas and the derivations. So we have completed motion in 1D now. We'll be moving on to motion in 2D in the next class, which is basically projectile motion and in general motion in a plane. We'll be doing that. Circular motion will be a separate chapter. Don't worry. Yep. So keep learning. Do not give up. If you have backlogs, cover it up. You have to focus your target on 99.9 percentile, guys. There is no denying that. If some students, some of your friends are not motivated, motivate them, because as a friend, that's your responsibility. That's why I use the word friend. It's your friend. You have to push them hard. Remember, we started this channel for all of you in South India, Northeast, and so many states where people like to learn in English, even students studying in UAE and abroad. So guys, it's a channel for you. Make this channel popular. Make sure all of you study together. We want all of you to get into the best dream colleges. So work hard. Do not give up. This fight should continue. You need to roar like a lion. Okay? So all my lions, continue your journey and leave a comment. Leave a comment that, sir, 1D is done. 1D done. 1D is done. That is the comment that you're going to put up. After watching the class, the PDF, the DPVs, everything is there in the Jungle Book. Do not forget to check it out. Also join the Telegram channel for getting the PDF. Bye-bye. This was Captain Shreyas signing off. Lions keep roaring. Bye-bye.